So we're going to look at the hydrogen bonds first, which give water its polarity. And these are very weak bonds, and when we say covalently, remember they are sharing electrons. But with the hydrogen bond now, what's happening is there's this kind of imbalance. If you look at the water molecule itself, they have this, the hydrogen side is a little positive heavy, the top of the oxygen here is a little negative heavy. And what happens here is, so the hydrogen is covalently bonded to the oxygen atom, but it's also, because of this imbalance, it's going to be attracted to electrons from other atoms, and they're going to be shared unequally. And that's what gives us this angle. And this angle is forming, and again, that's pointing to the hydrogen bonds, showing how it's a polar molecule. And that's what allows water and substances to dissolve, or water to bind to other substances, because it has that kind of both negative and positive hydrogen bond going on with the imbalance. And we see that when we diffuse things like salt, which we'll look at more closely here in a moment. But when we see salt, which is NaCl, it's very important before we move on that to understand the difference between the solute and the solvent. So we'll see that water is the universal solvent on Earth, which makes anything that really dissolves in it the solute. So in this case, if you put some salt in water, stir it up, let the water dissolve, the salt is the solute, making water the solvent. We mentioned this in the intro, that water is this vital component. It's very important that environmental scientists understand its properties, because what it does, it's this vehicle. It allows materials to be transferred from one system to another. And we can see it in the carbon cycle, for example. The ocean is a great reservoir for carbon. So from the atmosphere, it's exchanged into the water back and forth. You know, the sea creatures, you've all been to the beach and collected shells. Those shells were created from sequestering the carbon out of the water for these animals. Then it ends up, you know, limestone is a perfect example, and just through the cycle. And again, if you notice, through phosphorus, through the nitrogen cycle, water is always a component, which we'll look at in more detail in later lectures. So let's move on to surface tension and capillary action. The two pictures we see here, this is a perfect example of surface tension of water, and it's going back to those hydrogen bonds. And it's essential that we understand the difference between cohesion and adhesion. So cohesion is, we're looking at water being able to stick to each other. You may have noticed this before as you're driving and it's raining and your windshield has all these little droplets of water and they're streaking down your windshield. And notice how when one water droplet runs into another water droplet, they form a bigger water droplet. So water's attracted to each other, and we call that cohesion. And it's due to those hydrogen bonds. Another property of water we need to understand, though, is adhesion. And this is the ability of water to stick to other substances, something other than water. You know, it's raining out and you have to walk through the parking lot to your car. There's water sticking to your shoes or your rain jacket. So that's an example of adhesion. Very important we know the difference between those two moving forward. So surface tension, it's that skin. If we look at the swimmer here about to break the surface of the water, that surface tension this is a perfect example of cohesion, water sticking to each other. The pictures we saw here, this is an example of cohesion, the paperclip and the bug on the water. So it creates this skin, and here's our pool per se, and then here's the part where the swimmer is about to breach, but water still has that hydrogen bond wanting to stick together. Look, making that surface stay together and creating that skin. And you can do this looking at dropping water, putting water droplets on a penny. The water is going to stick to the penny, which is an example of adhesion, you know, the ability of water to form a bond with something that isn't water. But then as you keep putting the droplets on, and you'd be amazed there's more droplets than you could think, it's because of that cohesion. There's this the property of the hydrogen bonds sticking to each other and forming that kind of lens-shaped, almost like contact lens shape on the penny. And you could also try it with tap water and then add some salt water, where we can look at the polarity as well. putting salt in the water, making the droplets, and performing the two experiments, you may notice some changes because, again, remember, oxygen has the negative pull in the water molecule, hydrogen has the positive. So what it does with that salt water is it pulls the sodium and chlorine apart and attracting to it. And you'll notice that because these bonds are taken between the sodium and the chlorine, that you'll notice that with salt water, you couldn't get as many drops of water on the penny as if it were just regular tap water or distilled water. Moving on to capillary action. Now this is due to adhesion now. So remember, adhesion is water sticking to something other than itself. And this occurs when that surface is stronger than it breaks the bond between the water molecules. And another example you could do is putting food coloring and celery in water or colored water overnight. And it's a slow process, but slowly what we'll notice is water moving up the chain, up through the celery. And again, this is due to adhesion. And you can see as we move to the right here, the tubes are getting smaller in diameter. And you can see the smaller the tube, the higher the liquid will go. Which explains why if we have, this is General Sherman from the Sequoia National Park, a tree larger than the Empire State Building. These trees have to get water up to the top branches. The water needs to go through the entire tree in order for this tree to survive. And capillary action is a perfect example of how it does it. And if you look even closer at trees, especially trees this size, the branches start to taper off and get smaller the higher we get. And again, looking back at the tubes, this is how, through adhesion, capillary action, water is able to climb or go against the pull of gravity all the way up these trees. So very interesting property of water. Finally, boiling and freezing. We all should know that water is going to freeze at 0. It's going to boil at 100. So it's going from a liquid to solid here. It's going from a liquid to a gas when it boils. And because of this cohesion of water, it can exist in these three states of matter on Earth. And this is another reason why you and I are here today and all the other living organisms, because of this specific heat of water. And looking closer, we'll notice that the graph is pretty steady. As temperature increases, the temperature of this solid ice will go up. But notice that when their state changes, so when we have that liquid to gas, it evens out for quite a long time. Then once it's a liquid, it'll steadily rise. And you've experienced this as well. You've taken a warm shower or been in a jacuzzi, very, very warm liquid water, or you might have been into the Pacific Ocean, which is much cooler. So an example of how the liquid water can exist in a temperature range and allow life to survive on this planet. And then we flatline again when we go from a gas to a liquid. So what this is that specific heat, the amount of energy. It takes a lot of energy for one state to change to another in water. And finally, it's this universal solvent. Think of all the ways you've used water: to wash your clothes, to use the restroom, to shower, to clean dishes. Water is constantly being used. And the amazing thing is, it's one of the few liquids that can dissolve substances. This is mainly through diffusion. We already know that if you have a high concentration of something, it always wants to diffuse into a low concentration. An example would be, putting a drop of food coloring in a glass of water. If we walk away and come back maybe a half hour later, we all know that these glasses of water, the one on the right would be red, evenly distributed, and the one on the left would be green. So it's this amazing property of water that allows, again, things to be dissolved. We'll see where things do get accumulated in water, like chemicals and detergents and wastewater, where it causes problems, but it also allows things to diffuse and allow life on Earth. So that's the properties of water. You can always check back if you have any questions or issues. And as always, you can check the website. Everything's there for you between the units and the online lectures and then even the notes. Take care.